Hello, this is Eugene Bryce Energy Services. Just a short follow-up to the Energy Managers Association presentation that I did on 00 meter for anybody that wanted a closer look at that spreadsheet, because during the meeting there was a bit time constrained, so I thought I'd just show a couple more aspects of it. So I'll skip through presentation to get to my spreadsheet. So assuming that you've already seen the actual presentation, so this is the spreadsheet that I use and developed for the last couple of years. And as I said, the idea is you import your half-hourly data once it's cleaned up, and then you can apply different energy systems to your real data to determine the effect on your billing and consumption, import and export. So just go through the steps briefly again. Active import. So on this spreadsheet, and let me just format, fill. So just to tidy up the, I meant to just get the graph there, format. Get that? Yeah, so that's just the chart of the half-hourly data. So I had it clear because I like to cut and paste it into other reports. So again, along the top we have the half-hourly time periods all the way to 11:30, and down the axis we start with the 1st of January, all the way down to keep going, all the way down to 31st of December. So that's the idea. We have imported the real data. Now we also import, in the same way, the reactive data. So the kiloVARs consumption, and that goes into the reactive spreadsheet. So we now have our active and reactive imported from our half-hourly data. We get our consumption time of day. So again, this is us breaking down the half-hourly data into how much was night, day, green, amber, red. And if I go back to systems instruction, so this is where we get the time of day. So these are simply selection boxes that are applied to all the sheet to say whether a time is in night, day, red, amber or green. So you can see here from 11 p.m. to midnight we're back to green, but in some areas that could be amber, so we select amber, and that's for each half-hour period, time period. So some half-hourly data show it as HH01 to HH48. Other half-hourly data may show it as the actual time period, 24-hour clock from midnight to all the way, midday, and then on to midnight. So we've entered all of that. We have entered our reactive data, our active data. Then we go in and decide what our electricity rates are. How much are we actually buying the electricity for? And as I say, these are all in pounds. So that's 11.6 pence or 0.116 pounds for night rate, 17 pence for day rate. And in this particular example, the customer is on a fixed contract, so 17 pence and 11 pence. But if the red, amber and green charges applied, you would enter those values into these cells. And Finally, the triad charges, which could be about £45, but only for a very small percentage of time. So you can see here there's only a very small number, but it's multiplied by a big value number. Should be so. In this example, if we did apply triad charges for this customer, if I put, let's say, £45 in, you can see that the triad costs £1,600. So that is included in the fixed contract rate for this particular customer. But for most half hourly, you're on a pass-through contract and triad charges would apply. So I'll just set that back to 0.0007. I don't set them to 0 because sometimes setting a 0 cell causes problems. So actually, if I tempt fate and stick a 0 in here, what happens? Yeah, see, I get division by 0 signs over here. So that's why I just put it at a very, very small number. And oops, I didn't quite get that. Oh, that's why numlock 0007. So just keep it at a very low number if it's not applicable. And the final one here, pass through, simply use it as a fiddle factor to get your total cost to your annual bill. Total annual bill, obviously excluding VAT. And that gives us our baseline for consumption, top, and actual electrical cost down here. So I can use these quick links to go to consumption profile, go back to system, go to time of day, see the time of day. So just on the time of day, obviously Friday is a 6. So for each day, I use an Excel formula to calculate the weekday, and basically summing all this data. So just as a reminder, it's a sum if function based on the cell I want to look up and the array I'm looking up and the value. So check out the sum if function on Excel because I use it quite a lot. And then I scroll down and this gives me my summary table for each day of the week, Monday through Sunday, the total night kilowatt hours, day kilowatt hours, green, amber, red kilowatt hours for each day of the week. And then for weekdays, I sum 2, 3, 4, 5, 6. So for example, if I click on that cell, it's simply a sum of the night. And then similarly for the weekend. Now, the reason we do this is because there is no weekend amber and red. So those figures are this figure. So if I double click here, we're summing, adding the Friday, or excuse me, the Saturday and Sunday, the weekend amber and red to get a total green because they're all green rates. And then finally, again, the triad. Maybe you have better Excel skills, but you can either find the peak according to the rules of triads that have to be separated by 10 days. But I've slightly cheated in that because the bottom is December, if I look at December, I'm looking for the maximum in this data set, which is, I know that triads primarily occur between 5 p.m. and 7 p.m. and that is the month of December. So I'm just looking for the maximum in December, the maximum in January, and the maximum in February. So I know they'll all be separated by 10 days. Although that's not quite true. The maximum at the end of December and the maximum it could be early January, but it's just to get an indicative value for the triad that can be applied. And of course you can use your fiddle factor, or once you have real information you can apply that. So that gives us all this information along the top. So we have our maximum kilowatt, 69. we have our total night, day and triad values. And then we have some nice simple graphs of all of that. So we have these are the cumulative values. So we have our night and day for Monday just coming under 25,000. So we have 25,000 for day and 5,000 for night on Monday. Where am I gone? Oh yeah, sorry. There's our day at 20, just about 20,000, 5,000. So that's our total kilowatt hours in the day. Similarly, that's the summed or stacked day and night, and this is the stacked green, amber, red. And you can see the green because our timeline on the top, this is slight green extends into day, so that's why our green column here is slightly above the night column. The night column actually sits very nicely on the 5,000 figure, which is looks very, but it's just coincidental. And below, so that's across a week, so we can see if any weekday is slightly more energy intensive than any other weekday. And this is across the year. So we have night and day across the year. And finally, we have a week in December and a week in July, just to look at the differences. So this is peaking at 20, whereas this is peaking at 30. So we have a summer peak, and we may have actually captured this very large peak, which was a summer festival. This dip you can see in both, well, both are the same data, just colored for day, night, and red, amber, green. That was a COVID shutdown, so you can see that in your data. Something to bear in mind: if you have been affected by COVID, you should look at your data more carefully and decide if it's a true reflection of the business consumption. So that's our data in. If I go back to our systems, what we can look at is firstly our power factor, because we entered our reactive power. So if I go to profile, this is our reactive data, and it's actually our power factor. And if I double click the formula, hang on, see if I can let's move this cell out so you can see it a bit clearer. So the formula is active power over apparent power, and in order to get our apparent power, it's the active power squared plus the reactive power squared, and it's the square root of the sum of it. So it's Pythagoras theorem: a squared plus b squared equals c squared. And in this case, our a is our hypotenuse, and we have two right angles, and that's the formula to give us our power factor. You can see here in the data that our power factor, so there's 48 times 365, which gives us 17520. And what we have here is just counting the instances when the power factor is in these different bands. So that's just a simple count all of that array if greater than or equal to whatever, 0.95. And so this tells us this business has a very good power factor. Some businesses you'll find a much deeper spread, even down as far as even 0.7. But because this is say a commercial golf club, they do have air conditioning, which kicks in the summer. What I've also done is a little heat map. So this is conditional formatting to get an idea. So just zooming out, so you can see at nighttime, this is nighttime, there's significantly more red, but it's marginal red. It's just the color scale to give a difference. And that's air conditioners at night on a warm summer's evening. And that reflects the spike that we saw earlier. So that's power factor. Go back to systems. So the real advantage of this is applying other systems, and I can apply solar panels, wind power, battery store, all by selecting a profile. So if I go to instructions, the next step is select systems you want to apply. And if we want to apply solar panels, if I go to the profile, so just to explain a bit further, this profile comes from the year profile and day profile. So again, based on, for the day profile, if we look at the day, again we have our night and day amber driven from the sheet earlier. And what we're saying is, well, if we have a 100 kilowatt solar, what percentage of output will it be at each point during the day? So if we look at our solar profile here, and that's the solar profile up here, and these are just manually entered, you build a profile of percentage output for the solar. Similarly, for the year profile, if we look at our summer peak year profile, again we start 16% all the way to, well, 80-90% and that down again to get a profile of the output during summer. Though both, we then go to the solar panels, we've applied here. So I've selected from all the different profiles solar PV. So I could select, imagine, battery storage. So that immediately changes the profile of the solar. So I'll set it back to solar PV. And what each cell is doing, it's multiplying the percentage day by the percentage year. And these come straight from the day and year profile. And there's a very interesting formula. I'll just show you, if I click on it, there's a new formula in Excel. Let's see if I can make it bigger. No, that's not very good. Hopefully you can see it, called index and arrays. So I just type the formula I like into this cell and it populates the entire day profile for me based on the value I select in this cell. So I've selected solar PV, summer peak, and that produces that. Now I do have a spreadsheet where you can play with the various profiles, so curve profiles. So here you can basically, this sheet is just taking both year profiles and day profiles. So I've got heat pump profile displayed here. I can, let's say 50% max, and let's say put on solar. So basically I'm saying that throughout the year it's always at 50%, but you can see the time of day curve at the end. If I flip it and put 50% during the day, then we're at 25%. Bear in mind it's half hourly data, so it's twice. So if I put 50% capacity there and go for solar or summer peak here, you can see the summer peak profile there in 3D. So summer peak, switch back to solar PV. So this sheet is just for you to experiment with the solar profiles or the system profiles that you build in year profile and day profile. So you can just take any of these profiles and the spare ones that you can use. Similarly for year profile, there's other ones that you can just populate with whatever equipment you might like to see. So we take our, and I just go back to system, use the links. I only added the links for the EMA presentation, so hope you appreciate it. So if we go to our solar panel time of day, so exactly the same way as with the consumption, we see when the solars will actually be generating. And generation, I've put a minus on. So consumption is positive, generation is negative. And these are negative value curves, although it's obviously generation, just for the consistency of adding and subtracting the two load profiles. So we have Monday, Tuesday, Wednesday. So we can see that there's no nighttime production, which sounds about right for solar. And we can see again the shape of our solar profile. I've actually got this shape. It looks a bit jagged, but I got this shape based on one or two supplier quotes. So I'm not here to decide how much solar you get from a system. The idea is you go get a solar quote, and they have specialist evaluation software based on the angle of the roof and the angle of the panels to tell you how much you expect each month. And basically I just took their expectation and plotted it in this curve, because what I found is that they don't consider the netting, they simply subtract annual consumption with solar consumption and tell you that's the value. The purpose of this is to look at each half hour of each day based on 2021 data and say, well, if you had that solar profile, what would it do to your real data? And you find that in many cases you're exporting a lot more because you're simply not using as much of the electricity as you thought you would. So if I go to the systems here, you can see that we have 181 here, exporting 36 out of solar panels generating 102. So we have a 100 kilowatt system generating 102 kilowatt hours, which is good for solar. But you can see we still have a lot of surplus coming out. Now I can then start increasing the size of the solar because I've done all the... So if I double the size of the solar, I've quadrupled the amount of export. I've barely touched the winter targets, but I've quadrupled the export, which is interesting. And what I'm doing is, there's two figures that you need to consider with solar. The amount of solar that you actually use, because that mitigates the 17 pence. But the amount of solar you export is only at the value of the export rate, which here I've set at 5p. Some people may get a little bit higher, but you know, it's certainly more valuable to use the electricity on site or sell it to a neighbor than to export it to the grid. So that's a bit more in depth. So other things, so I can add to this mix all these other bits of equipment. So I've considered a 66 charger. So let's add a 66 kilowatt charger, which is 3 22s. And I just do that by selecting one. Immediately you can see a change in the profile. Let's look at the profile that we've given for EV chargers. So this is what the profile we've set for EV chargers. And what I'll do is I'll just select, I think, weekdays, battery weekdays. So this is the EV chargers just being used on working weeks, and EV medium use. So if I bump it up to EV high use, you can see I've added another charging cycle. So what we have here is somebody charging in the morning, early afternoon, and then late evening. And what we can go back is see the effect on our system. So immediately what you can see here is spikes in export on the weekends when nobody's using the EV charger. But what you can also see here is additional demand during the week because of the EV charger. So if we look at the consumption here, our EV charger at 66 kilowatts requires 132,000 kilowatt hours, which is almost as much as the golf club consumption itself. So what you can do is begin to play with the balances of values. There's a bit of a fiddle factor here, you know, if you want to have a bit more fine tuning. But similarly, you know, you can add a heat pump, solar panels, wind power is a very interesting one, battery store. So if I get rid of the EV and add the battery storage, very interesting. So I look at the profile, battery store. Bit difficult to see, but effectively what we're doing is we're charging the battery at night, and that's why it's positive, and we're discharging it during the red period, which is negative. Now, one thing to note with batteries is, go back to day profile, battery storage, it must add up to 0. So for example, there I'm saying we're charging at 50% capacity during the night time, but we're discharging 100% during the red time. But the positive 50 for charging and the negative 100 for discharging needs to add to 0%. So just bear that in mind. So I'll go back to system. How has it affected our electricity bill? So we have a total cost here of 30 grand. Our new electricity is 14,000 import, and we're selling for 6,000. So the battery has had a very positive effect on our system. Question is, what costs the battery? So hopefully that was a little bit more in depth than earlier. Feel free to drop an email if you have any further questions, but do try and get into it. There's no security on it, and if you have any good ideas as to how that can be improved, do let me know. So thank you very much. Hopefully you enjoy this slightly more, and I'm at this one on the 30th of March. So thank you very much.